Okay, as you start section 9.3, you're going to see that there are a handful of objectives that we're going to accomplish, numbers 8 through 12. So we're going to review how to rewrite a logarithm as an exponent and evaluate it, which you did last year in Algebra 2. 9, rewrite base 10 numbers as exponents and logarithms and evaluate. 10 and 11, we're going to solve exponential equations by writing as logs. And then the other side, solve logarithmic equations by writing as exponents. And then the last thing is graph log functions describing properties such as domain and range and what have you. So really, it's really three main concepts, just going from exponents to logarithms in general, going from exponents to logs using equations, and then just looking at the graphs. So let's go ahead and do that. I first want to start by talking why do we have logarithms and how do you say a logarithm properly. Logarithms exist out there to help us deal with extremely large numbers and extremely small numbers. The science field primarily will be using logarithms. When we're talking about things dealing with distance, when we're dealing with astronomy, or when we go into maybe sizes of molecules. Now, how do you say logarithms? The right way to pronounce it here is a logarithmic equation. And what you would say is y equals log base b of x. So if I take a look at this on the multiple choice, they're going to ask us here which statement is read. P is the log of q to the base s. Okay. Now, this is the base of our logarithm, so that's base b. So what you want to do is find the one that has base s. So again, over here, p is, so that's p equals, so it has to be c or d, is the log of q to the base of s. So that would have to be this. So that's how you say the logarithm and match it up. Now, let's look at its corresponding part dealing with the exponent. You can rewrite any logarithm to look like an exponent and an exponent to a log. And we're going to do that throughout the notes today. Here's how you do it. I'm going to actually show you the backwards. Go to the exponent. This is the easiest way to see it. The exponent has base b and the log has base b. So I always start with that. And I just do this trick. I kind of do a swirl. So I start at base b and I swirl around to the problem. So of the exponent, it's base b. Therefore, I could rewrite this and say log base b. The next variable that comes up is x, so that's what goes here. And then it has to equal this y over here. And in doing so, if I take the exponent and kind of swirl around and rewrite it, I can get the logarithm. Okay? You know, conversely, if I have a log, I just start at the base, and I say fine as log base b, so it's exponent base b. And I kind of do that swirl around again. If I swirl around, it's b to the y power is equal to x, which is this original function here too. So we're going to be practicing a lot of rewriting exponents to logs and logs to exponents in this section and going on in the chapter. So as we talk definitions, they first want us to evaluate the log of 512 to the base of 8. Well, let's write it. So it is the log of 512. It's a base number of 8. That base is that little subscript down there. Okay. Now, they want us to evaluate it, so they want to know what it equals. That's the question. It equals x. How do you figure this out? Here's what you want to do. Whenever you have a logarithm, rewrite it as an exponent to understand it. And again, I always start with the base, and I just kind of swirl around. So I can go backwards here. I can do 8 to the x power equals 512. So 8 to the x power is 512. So when I say, what is log base 8 of 512, the real question I'm asking you is 8 to what power is 512? Well, if you go ahead and figure that out, it's going to end up being the number 3. So log base 8 of 512 is the same thing as saying the number 3, okay? Because that's what 8 to the power of 3 is 512. So let's look at a couple more. Part B here. The question is, log base 8 of 1 over 64 is equal to something, equal to x. To do this without a calculator, here's what you do. Again, I'll do that swirl. I start with the base and I just swirl around to here. So I can rewrite it as an exponent. It says 8 to some power is equal 1 over 64. Well, you got to think about it. 8 to what power is 64? 8 squared is 64, right? 8 squared is 64, but I need 1 over 64. How the heck do you get a fraction when you have that exponent? You make this a negative. So it's 8 to the negative 2 power is 1 over 64. So the answer to this problem is x is equal to negative 2. Or you could say log base 8 of 1/64 is the same as saying the answer negative 2. Right. The last one on here, let's look at this. Log base 8 of the 7th root of 8 equals what? Well, I'm just going to do this. Maybe we use a question mark. It equals what? Fine. I can rewrite that. Here's what I do. I take 8 to that power is equal to this. So 8 to some power is equal to the 7th root of 8. Well, these things can look identical. I can rewrite the 7th root of 8 as an exponent. So this would be 8 to what power is equal to 8 to the 1/7 power. Well, what's the answer? To make those two sides match up, the answer is 1/7. So in this case, this answer equals 1/7. What I would say is log base 8 of the 7th root of 8 is equal to the number 1/7. And that's how you evaluate a logarithm. You just always convert it to an exponent and think of it from that perspective. Now, if you want more practice with this, listen to the slide. If not, fast forward to the next one. Go ahead and look at these two problems, or these three problems. I'm going to pause the video and pop the answers up. So pause your video, see if you can do these for extra practice, and pop back up on the screen. I'll show you the answers. If you're good with that, move on and skip past the video. If not, listen to my explanation of each problem. Now, these are the corresponding answers you should have gotten. This right here was actually a 4. Careful. If you got them, great. If not, listen up. Here we go. Part A. The log of 625 to the base of 5. That can just be written as log base 5 of 625 is equal to x. Always just take a logarithm and rewrite it as an exponent. So it's 5 to some power x is 625. If you want to use your calculator, it's going to be 4. Part B. I just set the problem equal to x already, and then I rewrote it as an exponent. 4 to what power is 2? 4 to what power is 2? Well, they had to take the square root. As an exponent, the square root is the exponent 1/2, so it's 1/2. C. Rewrite it. It's going to be as an exponent 6 to some power is 36 to the negative 1.5. These two are not comparable until the bases are the same. So make the bases be the same. The only thing you can do is rewrite 36 as 6 squared. Now that the base numbers are the same, you can compare them. Use your property of exponents. 2 times negative 1.5 is negative 3. What makes these two sides match up? X has to be negative 3. Now this next slide is the 9th objective. It says rewrite base 10 numbers as exponents and logarithms. And base 10 numbers are this, by the way. Base 10 is the counting system that we use around the world. It means we count by tens. Our number systems, counting system, everything changes by tens. So if this is the ones position of a number, you count 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you hit 10, you go on to the next position. And that's what that means, is we count kind of by multiples of 10, which gives us to the next position. Okay, so it's base 10 number. What they want us to do is we can do this. Log base 10 of 100 equals what? Easy enough to figure out. Set it equal to x and rewrite it as an exponent. That means 10 to some power is 100. Well, you clearly can tell here that 10 squared is 100. So the answer to this problem is 2. If you were going to go to the Culver's and order 2 hamburgers, you could actually go to the drive-thru and order log base 10 of 100 hamburgers, which would mean 2. So give it a try sometime. All right, let's evaluate these to achieve our objective. Part A, find the logarithm of each number to base 10. So here's what you're going to do. They want you to realize that they want base 10 of 100, so just do log of 100. Now, in base 10, we don't write the 10, but if you can, if it helps you, put the little base 10 in there. It's implied that it's there. Just like a square root means a 2 is there. Okay, now just solve it. It equals what? We just did this, right? So 10 to what power is 100? The answer here was 2. Okay. Now, for the next one, we're just going to do this. Let's just put the log in base 10 tucked in here equals to x. Rewrite it as an exponent, so it's going to be 10 to some power is equal to 0.00001. Okay. Now, if this was 10 to the 0 power, that'd be the number 1. 10 to the negative 1 power is going to be 0.1, right? 10 to the negative 2 is going to be 0.01. Negative 3, negative 4, and negative 5. So what this has to be is 10 to the negative 5th power is going to equal this answer. So this case, x is negative 5. Put it in the calculator. Raise 10 to the negative 5th power and see what you get. All right, a trillion. Let's talk about this one. We're going to have to write it out. A trillion has a lot of zeros in it. It is going to have, in terms of our groups, we have hundreds, thousands, millions, billions, and then trillions. So we have 4 groups of 3 zeros. So it's going to look like this. Log base 10, it's going to be, again, hundreds, thousands, millions, billions, trillions. So the question is, 10 to what power is going to equal the trillion? If you go ahead and do that, you're going to end up counting that there are 12 zeros behind it. So in this case, x has to be 12. Put it in the calculator if you want to check it. All right, the last one is part D. Let me just write it. Log base 10 of this is equal to x. I'm going to rewrite it as an exponent here in the red. So 10 to some power is equal to 10 times the square root of 10. Here's what I'm going to do. 10 times the square root of 10, if I rewrite this, folks, this is 10 to the 1st power. This is 10 to the 1/2 power. What you do in mathematics is you would add those exponents. So 10 to some power is equal to 10 to the 3/2 power. Therefore, x in this case is the number 3/2. So log base 10 of 10 times the square root of 10 is the number 3/2. I'm going to go ahead and skip this page, so let's just move on to some calculator problems. Now, those previous slides wanted you to show some work, and if on a test or quiz, if it says without a calculator, that's the work I would want to be shown. Show me you can do a log to an exponent and get the answer. These right here, they want you to use the calculator, and it says here the common log of each to the nearest thousands. Common log base 10, by the way. So let's do this. Part A, you would write it as log of 45.8. Now again, we don't typically write the 10 in there, but if you wanted to see it, it's log base 10 of 45.8 equals something. If you rewrite this as an exponent, what you're going to get is 10 to some power equals 45.8. It's not going to work out nicely, so what you would use is just the calculator. And as simple as this, folks, go to the log button on your calculator, hit log 45.8 and get enter. You're going to get that this answer here is going to be about they want it to the nearest thousands, so we're going to have 1.661 is the answer. And then you're going to go ahead and do that for part B. On part B, we're going to do the same thing. This would be 10 to some power equals 458. There is not a nice integer answer for that, so just on the calculator, do log of 458. And what you're going to get on this one is 2.661 is the answer. And then the last one, just do the log of 0.00458. And what you're going to get on this one is slightly different for part C. The x value, if you solve that, you're going to get negative 2.339 for the logs. Now the only thing I want you to note about the log button on the calculator, that log button is only for base 10 numbers. If this was a base 8 or a base 5, you could not use that button, so just be cautious of that. All right, we're going to get moving along with these objectives. The next one is solve exponential equations by writing them as logarithms and getting an answer. This is the easiest way to do this problem. 10 to what power is equal to 7? Whenever you have to solve for the exponent and it's not a nice, easily thought out number, easiest way to do it is take the exponent and rewrite it as a logarithm. So here's what I'm going to do. The exponent can be written as a log very easily. This is, rewrite it like this. It's log base 10 of 7 equals x. Again, I just kind of do that the swirl on it and I always get the right answer. Now this is log base 10 of 7. That's a calculator problem. Go into your calculator, hit log of 7. You're going to get that x is approximately 0.845, which we couldn't do in our head. We would need a calculator for that one. If you'd like to see another example, here's a great one. 10 to what power is 14.5? 10 to the first power is 10. 10 to the second power is 100. So we know the answer has to be in between 1 and 2 somehow. I'd have to sit and guess, but I'm not going to sit and guess with a calculator. I'm going to take it, rewrite it as log base 10 of this equals x. So here it is, log base 10 of 14.5 equals x. Hit the calculator on that. We're going to get x is approximately 1.161. Again, my rational reasoning made sense. I knew it had to be in between 1 and 2. 10 to the first power, obviously, again, is 10, and it's close to 14.5. So logically, this answer has to be closer to 1 than it is to 2. All right, let's move on to the fourth objective. It's number 11 in the list. Solve logarithmic equations by rewriting as exponents. The easiest way to solve this, by the way, is first to realize it's log base 10. So if you'd like, just write in the little 10. And this is hard to see. So logarithms are hard to understand written as log. Just rewrite it as an exponent. Again, they all work the same way. I'm going to start here at the base, and then I just kind of swirl around. So really, log base 10 of x equals to 2.873. What is x? It just means 10 to the 2.873 is equal to x. So put that in your calculator, because this is definitely a calculator problem. You're going to get that x is going to be approximately 746.4. That's all you have to do. Logs are actually easy if you rewrite them as exponents. Let's look at another. This next one here is just using some different variables. They want you to solve for t. Log of base 10 of some number is equal to 3.41. Easiest way, I like to put the 10 in there to see it, and I start with the base and I kind of swirl around. So 10 to the 3.41 power is equal to t. Put that in the calculator. T is approximately 2,570.40. And you could double check that answer, by the way. Go to the calc, hit the log button, do log of this number, and you should get 3.41. Now let's take a look at this example and just solving a logarithm. Easiest way to do it is to make it an equation. Is just say it equals x. That's now an equation. So log base 4 of 8. Fine. If I have a logarithm and I don't understand it, I just rewrite it as an exponent. So it'd be 4 to some power equals 8. Now 4 to the first power is 4. 4 squared is 16. So it's not a nice whole number. But can we figure this out without a calculator? You can. The trick here is you want to stop and think, can you rewrite these to be the same base number? And I can. 4 is the same as 2 squared, with a little x out there. And 8 is the same as 2 cubed. So when you do that, what we now have is we have 2 to the 2x equals 2 cubed. So the question is, what's going to make these two exponents equal each other? All you need to do is figure that out. So make those two exponents equal to each other. 2x equals 3. In that case, x would have to be 3/2. So the answer to this problem is actually 3/2. What makes this work? If I were to put 3/2 back in here, 2 times 3/2 is the number 3. So then both sides of my equation would balance. So if you have to do it without a calculator, or if you have to show work, you would have to go in and think through it this way. Okay, if you want some more practice on doing this that's not base 10, here we go. Evaluate log base 9 of 3. Again, I'm going to come on in here and just say it equals x, make it an equation, and then just rewrite it as an exponent. So 9 to some power equals 3. There is no nice whole number integer for that, so what I'm going to do is try to get them to be the same base. 9 is 3 squared. Don't forget the x was there. And this is just 3 to the first power, by the way. So the bases are the same. What values is going to make these exponents balance? Well, just set them equal to each other. What makes 2x equal 1? When x is 1/2. That should make sense. If I put 1/2 in here, 2 times 1/2 is 1, and you'd get 3 to the first is equal to 3 to the first. So log base 9 of 3 is equal to the number 1/2. If you'd like another example on this, here's the last one we're going to look at. Log base 125 of 25 is equal to what? And it's without a calculator, which means show me the work. If this was on a test, you might have your calculator handy, but if you do not show me the work for this, I won't give it to you. It equals what? Just rewrite it. 125 to some power is 25. They are clearly not the same base. I can rewrite 125 as 5 cubed. And the x is there. The same base I need? Well, 25 is 5 squared. So now what you're going to do is 3x equals 2. To solve it, x is 2/3. So log base 125 of 25 is the same as saying the number 2/3. I want to wrap up these notes with addressing the very last objective, which was number 12, just graphing the logs and talking about domain, range, and what have you. A logarithm comes from an exponent, which means this. Logs and exponents are inverses of each other. If you look at this notation, this is an exponent base b of x. This is log base b of x. Notice this here, this -1, that is a superscript. It's just a label. It is shorthand for the inverse of a function. All right, let's take a look at an exponential. And they've done a nice job of color coding this. Look at 2 to the x power. It is a blue line. It's an exponential growth function. What you're going to see is its corresponding inverse. By the way, inverses flip over the line y equals x. You're going to notice its corresponding blue graph is log base 2 of x. That's the inverse function. Where does that come from? Folks, definition of an inverse. Take y equals 2 to the x. Okay? Find its inverse. That means flip-flop x and y. Fine. I need this thing to be solved for y. The easiest way to solve it for y is rewrite an exponent as a logarithm. So what I do is I take 2, which is the base, and I do that swoosh around. So this is log base 2 of x equals y, which is this equation right here. This equation and this equation are inverses of each other, because mathematically that's how you get it. Okay? And you're going to notice the same pattern. If I take a look at the 3 to the x power, which is right here, its inverse is log base 3 of x. You would find the inverse mathematically the same way. Now, the details on domain and range, just look at it. They're saying here the domain for a log function, if we just look over on the functions on this side here, the domain is going to be all positive reals. Notice these graphs are only in quadrant 1 and 4. They're not over in the negative x's, so they're just positive real numbers for the domain. The range is all numbers. The height of this graph goes all the way up and all the way down. The graph contains the point 1, 0. This number 4, this graph is said to be strictly increasing. If you look at these 3 graphs, and you read it going up to the right, like they continue on, they are continuing on. All 3 of those graphs are increasing. The end behavior here. As x gets larger, these graphs increase without bound. As these x's get bigger over here and you crawl up on the graphs get bigger and bigger. They never stop. It's without bound. 6, as x gets smaller, it approaches 0. Okay? That's what's happened. These x's right here, as they're getting smaller and smaller, it approaches 0. It hits an asymptote, by the way. Right? And that's what this is. The y-axis is the vertical asymptote for the logarithmic function. And that is the basis of covering section 9.3. For the homework in this section, you can skip 15, 19, 20, and 23, and just let me know what questions you have.